Hello, everyone. Welcome to another technical stream for Global Hack Week here at Cloud Week. We had some super cool streams yesterday, and today we will be getting started with the first edition of how's it called, of IoT, Internet of Things. If you are familiar with it, then that's going to be super exciting. And if not, I'm pretty sure you will learn a lot throughout this stream. And I think it's very helpful because we will not only be learning about software itself. I think yesterday for the introduction to cloud computing, we saw kind of like some technical topics, and we also discussed basically how to host your portfolio website online using GitHub Pages. But today, I want to introduce you a little bit more into the hardware used to build cloud projects or IoT projects, which is something that I really, really like talking about. We have some hellos over here. And before we get started, don't forget to check in. Here's the link. I already sent it over on the chat. So yes, don't forget to check in because otherwise that's the way that you are checking in into getting your points for the weekend. We have a question over here. What's IoT? So itself, the letters basically mean Internet of Things, and we will be learning about what it is in some more minutes when we start presenting the content. Before we start, I just want to say that I'm excited to start creating this set of streams that will be focused more into the hardware part. And even though we don't have hardware right now, like in our hands, we will be using virtual hardware, which is basically it is basically the same as if you were going to have like the physical hardware, but we're going to simulate it. And I'm pretty sure you will see it in a while what I'm talking about. I've been waiting for Cloud Week since January. Wow, that's that's way back. Very glad to have you here. Emulator, kind of. I mean, you will be able to simulate what you will do with physical hardware, but I promise it's super easy to get started. It's just like a website where you can basically run all of the pieces of hardware separately. And for today, we're going to use a super basic website just to run like the hardware part and do some code over there. And then for tomorrow, we will actually be simulating the cloud part. Why? Because it's not very simple to get started. So first, we're going to learn the basics, and then we're going to connect it with the internet because it's Internet of Things. Awesome. So let's get started. I'm going to share this the super cool slides that I prepared for you. And let me just share my screen. There we go. So before we get started, I will introduce myself because I think I haven't done that for the first 10 minutes of the stream. But yes, my name is Jocelyn, and I'm a coach here at Major League Hacking, but I was also a previous fellow. So if you have any questions about the fellowship and my experience, you can always ask me as well. Some of my fun facts is that I like salsa dancing and also the Minecraft Bee plushies, which is something that I really enjoy collecting, which is very specific. You can ask me about mechanical keyboards, robotics, or neurotech. And this is stream is specifically talking about things that I get to see in my robotics career because I'm a second year student at university and I study robotics. So the things that I will be showing you today, it's basically some of the introductory things that we see in my career, which in this case it's robotics. And I'm also a GitHub campus expert. So if you want to join the program, you can ask me as well as my experience if you want to learn more. Awesome. So let's get started. What are we doing today? So we have a set of cool things prepared. As I mentioned, this is a two pieces stream. So today it's going to be a little bit more chill because we're just going to see like the basics about IoT, so everyone is on the same page about what we will be doing. And after that, we're going to start building with some Arduino components, and I will let you know what Arduino is and how to use it. So you don't have to worry about it if you have never heard these words before. This is super beginner friendly, and I'm pretty sure everyone will be able to finish with something by the end of the stream. And finally, oh, oh, yeah, there we go. I'm sorry. And finally, we're going to run our first hardware simulation on the cloud, which is going to be pretty cool. And we will be able to turn on some LED lights and perhaps move some motors today. Let's see which components we feel like using. I will leave that up to you in a few moments. Yay, robotics is cool. Yes, I'm very excited about that as well. I have an Arduino. Yay, that's nice. Then you should already know some of the basic concepts that we should be covering in today. And my goal here after this stream is basically that you will be able to create your first hardware circuit and test it, which is basically what IoT does. I mean, IoT, it's basically talking about the hardware, but like on the cloud, as we learned yesterday, the different types of clouds and how it works. But now we are actually seeing the components needed to make that cloud thing work. Great. So, as the direct definition of IoT, because I always like to place things like very directly and then try to place like some examples so we can all understand what we are talking about. So, IoT, it's Internet and then of things. So, I think that, like the first time that you hear that word, it's like, like I'm talking about different objects and different things, but why are they connected to the internet? So if they're connected to the internet, then that's probably because they have to control something or they have to do something like over the internet, right? So what it basically means is that you can interconnect different objects or different physical devices that can be, I don't know, lights, they can be like a microwave, you can have like an Apple Watch, you can have like a TV. Almost everything that has a circuit on it can be connected, interconnected into Internet of Things. And these are just physical objects that we see on our daily basis. And they have to be embedded with software, sensors, and super for sure, connectivity with the network. Why? Because if you want to send information, you need to have some sort of connection with your Wi-Fi or whatever method of internet that you are using in order to exchange data for itself. Those Uno R3 work for this? Yes, that's it will work. Because why? It is a microcontroller, so it will work. Basically, excited to learn. Yes, I'm very happy that you are all very excited to learn about hardware. I know that the majority of the streams that I have done, or perhaps that you see like a global hack week, are related to software. But as I study robotics, I said, okay, why not do something a little bit more on the electronic side or on the hardware part in case we have some hackers that want to build hardware projects. So the things that you will learn today, you can also apply them into hackathon projects. And let me tell you this, that when you go to a hackathon and you present like your software part, but then if you have something physical to show to judges, they will very probably be impressed by your abilities. Because using hardware is not very easy. It implies having more room for mistakes, and you will see why in a moment. Because when you're talking about a physical devices that you control in your daily life, then there are more propense on not working correctly because perhaps like you didn't connect it something correctly, or it just stopped working, or you burn it with a battery that had high voltage. Many things can go wrong. So people that can actually pull off hardware projects are very, but those are impressive projects, at least for me. I mean, perhaps I'm a little bit biased because of my career in robotics, but I like seeing those types of projects, knowing that there's a lot of work behind them. Great. So as for now, we all should know that IoT means Internet of Things, which is basically interconnecting different devices through the internet. Great. So now you might be thinking, okay, then cool. Okay, I can connect my lights. I can connect like my phone, but why is it important? I mean, where would I use it? They have different benefits, and I like this diagram a lot because it basically mentions all of the things that you can do which you can basically connect any device. Anybody can connect anywhere, like literally anywhere, any business, any company, any network, anytime that you want. It will always be available for you to use. So that's pretty cool. I mean, you can basically access, any resource through the internet, which is basically just like a physical device. So you can see that in your daily life. Uh, yes, in most of the things that you see on your daily life basis have Internet of Things. For example, if you have a camera, a security system on your house that uses a camera, and you can see the camera from your phone when you are, I don't know, on vacations, then that is Internet of Things. Or if you have one of those devices that are like the HomePods or like the Alexas, those are Internet of Things as well, because you can basically control your lights, or you can control any device that has like that internet access through your Alexa or through your HomePod, or perhaps your speaker or your computer. So all of that is Internet of Things, and those are like kind of like the most common examples that you can see in real life. But sometimes we don't realize that they are actually part of something bigger, which is IoT. And if you can see in here, in the diagram, all of the different devices are connected between each other, and perhaps it's like a central user that controls them as well. It can be your phone or your computer, or if you have a central system on your house, it can be that as well. And another important thing to know about IoT systems is that they use sensors. So they use different types of sensors to detect what's going on in the environment. So let's imagine that perhaps you have a camera. So the camera has a lens, and that's basically a sensor. Perhaps we are thinking on more direct examples of sensors, such as, I don't know, like a temperature sensor for your AC, or a sound sensor if your speakers are too loud. Those are also sensors as well, and they detect different types of data. So I placed some of the different types of sensors that we can see most commonly. So the temperature, as we all might have thought, it's to measure temperature on your house or outside or wherever you are in the room, in case, I don't know, you want to know if your room it's like a room temperature, if it's too cold or if it's too hot. That's also valid. We have image, which is just basically like a camera that's most commonly used on security systems. We also have the gyro sensor, which is basically to detect like different angles. For example, in a car, in an autonomous car, you can detect like the angles where you are going. We have the IR and the RF, which are just basically to detect obstacles. So in case you want to detect if you have an obstacle in front of you, then you can measure that as well. And these are just some pictures of some of the different sensors that are out there. They're very tiny. For tomorrow, I will bring you some examples of sensors so I can show them like on the screen. Right now, I don't have any of this with me, but I have some of those. I think I have this one, and this one. So I can bring them in tomorrow to show you like a live demo of how they work. I mean, today we're going to use them, but like in a simulation, which they will look basically the same, just that they will be like in our computer and not like in real life. Yeah. But if you test whatever you built on the simulation, then and do that exact same thing on your computer, then it will work exactly the same. And they're very tiny. Some of them are just like this big. They're not very large, because these ones are small because they're meant to be like for educational purposes. But then when you go out into the professional sector, they might have bigger sensors because they're for bigger machines and more professional spaces. But these ones are just like to test out, and they still work super good. And if you are into hardware, then you should probably be been seeing a lot of these already as well. Great. So things that we have learned so far about IoT, we already know what it means, which is basically interconnectivity between different devices through the internet. And we know that to have IoT and to make it work, we need to recover data. So for that, we need sensors, and sensors are just basically a way of us with interacting with the external environment. Oh, I like this question. Can IoT be done with an FPGA? I mean, I'm thinking about it, and it might be super hard to do it because I'm just learning about the microcontroller in VHDL. I think that's the words in English, and it's very complex. I mean, it's very robust, and it's like a low level of programming language. So I'm wondering. I mean, I think there's a way to do IoT in there, just that it will take a while to learn how to do it. I mean, I don't know how to do it. I'm just learning basics about the microcontroller, and that's nice because actually in my class we have a project where we have to use that microcontroller, well, that FPGA, and it's basically to build like a video game using that board. Um and the and we need to use the board like as a controller, so like for example as an Xbox controller, and we need to code it in VHDL. Yes, Verilog it's like the B, and then I think HDL is just like the, yeah, Verilog. Yes, I know they are two main. I think that's one, and the other one is BHDL. Uh, I took work with BHDL a semester for a class. It was really hard. Then I'm doing the same right now, and I mean I'm liking it because it's very challenging and it's very different to what I have worked with before. So, for example, Arduino or C++. So I took it as a challenge. I mean, I will let you know how it goes. I can even show you like the device tomorrow if you want as well. It's much bigger than an Arduino. Also, the STM 32. That's also another one for the hardware fans. Well, but moving on. That was a nice chat. I really enjoyed that question. Great. So to work with IoT devices, you need to have different sets of things. So to work with this, you actually need to collect data first. So you need to do that using sensors, and then you need to transmit that information packages through the internet. So today, what we will be basically doing is collecting the information, and tomorrow we will be transmitting that information, and we will see how through the internet, perhaps through an API. It might be the smartest thing to do. And then devices will actually do something or actuate based on triggers produced by sensors or processing devices. So imagine that you have a light bulb and you only want the light bulb to turn on when the room temperature is above 30 degrees Celsius. So to do that possible, you need to have sensors collecting data continuously in order for your device to actually know what to do. And it's not just having like the sensor in there. You actually need to connect it somehow using some sort of information packaging, different types of protocols over there throughout the internet. We will not dive deep into those topics, but we will just see like the basics for that. And then after that, you also need to be able and open to receiving information from other devices, because you need to be receiving info from different sources, perhaps in case that you have like a larger system, then that's what you need to do. And it also works for communication assistance, which is just basically the same. So yes, the important things: you need to collect and transmit data, and you need to act based on triggers produced by sensors or processing devices. Those are the most important things to have. Great. So wrapping up with the explanation part, IoT is literally everywhere, and I think the most common parts where we have seen it, it's on your house, perhaps if you have some of these devices, or more directly in robots or drones. More, I think direct appliances can work as well, and then as well in smart cities, in more, yes, in more modern cities as well, or also in healthcare. That's also another area over there. Can you explain about IFTTT? I have no idea what's that. If you will mind explaining, perhaps I'm not understanding it or I haven't seen it. So if you can provide a nice description, perhaps I can I can have an idea of what it is. But just by seeing it like that, I have no idea what you're talking about. Awesome, great. So let's get started. I think I placed great. So before we move on to the workshop part, um, we are going to learn about Arduino. So right now, all that you have to know is on this screen, which is just basically a picture of how the hardware will actually look in real life. So this is an Arduino board. It is a microcontroller, which basically means that you can connect, different devices, and it's kind of like the heart of your robot or of your product, if you would like to see it like that. It's kind of like the brain that connects everything. So if you see it in a more software side, for example, in your computer, you have different components. You have like the how do you call it? You have like the hard drive, you have like the RAM, and you have the processor, which is kind of like the thing that connects with everything. So you can see the Arduino kind of like a processor. I mean, it's not a CPU. Don't how do I say? Don't try to compare the Arduino with your CPU, but it's kind of like the same concept because it controls different things. Just that it doesn't work as a computer if you would like to see it in that way. If then that yes, I don't know. Yes, it is something related to connected devices. Perhaps I will search it in a while on the stream so we can learn what it is. Great. So for the Arduino part, Arduino is basically the brand that makes these boards, and these are boards just like kind of like this big. They're very it's very small. It's not very large. And on your Arduino board, you have kind of like the different pins in there where you can connect different things. So for the pins, you can basically connect in there like kind of like all of your external devices. So you can connect like your sensors, you can connect like your motors, your battery, everything that you want to control with has to be connected on your Arduino board. And if you can see, all of the pins have like different numbers and they have like different weird words, but they all have a meaning, I promise. Perhaps I will explain some of them when we are actually doing the example. Because I think if I just start explaining right now, like for example, what digital PWM is, or like what this means, then you might be confused because you will not be able to relate that with an example. So I will be explaining this when we start moving on to the example, which we will do in a few minutes. We have some questions over here. It looks like a home automation software. Oh, that's nice. Yeah, it's trigger-based automation. It's loosely relevant to the topic. No, I mean it's related. If it's related to connectivity in between devices, then it's definitely related. And everything is related to the conversation. Don't worry. I mean, I've had streams where people talk about like random topics on the chat, and I always enjoy that because we have a nice side conversation while we all are learning something. So we are actually having fun, and that's very nice. From Italy. Oh, all right. Awesome. Great. So let's get started with the activity. And oh, no, that's for the end. We don't want to do that right now. There we go. So for the activity, we're going to use a website online, and I want you all to create accounts on this website, which is very helpful if you are working on more applied engineering fields such as robotics, mechatronics, mechanics, electronics as well. That also works, or perhaps some really passionate software engineers. It will work as well. So it's basically called Tinkercad. And let me share this link with you on the chat as well. Oop, give me a moment. Because I need to make this. Yes. So everyone go to tinkercad.com, and you will see that Tinkercad has basically different things that you can do. So it's not only about hardware. You can also do different things such as like circuits, and you can also do designs online. So basically, people who are into mechatronics or mechanics, perhaps you all might know what CAD is, CAD, and that's just basically to making designs of your, I don't know, your cars or your robots like online. It's kind of like a nice modeling software. And this page is really very beginner friendly. I remember when I was learning about robotics, like the first things that I learned about electronics was over here, because it's honestly it's a very nice piece of software where you can basically build cool things. And we are going to be using this one. So right now, let's just log in or sign up in case you want to create an account. I would do, I think I have personal account. Let me remember my account. So everyone go ahead and start creating your free account on Tinkercad. Let me see if I have mine. Oh, there's mine. Great. And I have some of my designs when I was very little. Oh, this one was recent one. This one is like 4 years ago. What's in here? This one is like 3 years ago that I was trying to do like how's it called? Like a 3D printing thing, and it was very bad. It was like for the anniversary of my parents, and I wanted to print them something, but it was not very good. I was just learning. It was like 3 years ago. I'm not actually a lot into designing stuff. And then this is another one. Oh yeah, this is another one of a 3D printed hand, which is also very cool. I mean, it's not the best, but I was trying. I was trying. And these are so just some basic circuits. Great. So yes, I mean it's like 4 years ago, so it's not like very long time ago. It's still a lot of memories. I mean, there's just like 3 projects, so it's not a lot. I thought I had more, perhaps in another account. I don't remember. Great. So I will give about 3 minutes for everyone to create your account, and then we will come back and I will ask the chat if you already are like on this same page. Great. So I think that was enough time for everyone to create your free account. Can I get a chat check on people who already created their accounts and they're seeing like a similar screen just as mine, just so I know if we are good to go? You can do a thumbs up or just say like we are ready, just so I can know. This is such a cool app. Yes, it's pretty nice. Honestly, you can do a lot of things over here. You can do 3D design circuits, and you can also do coding blocks over there. Great. I used to use IFTTT for everything. It was really popular for a long time. I wonder why it lost stream though. I will search it right now because I'm actually now curious about it. Like if I have seen it before. I think I missed an T. Let me see. Honestly, I have not seen it. That's weird. That's super weird. Huh. I mean, it looks nice. It looks nice though, but I honestly I haven't heard of it. I'm impressed. Great. We have ready, thumbs up. Okay, great. So we're good to go. And for this stream, as we are going to learn the Arduino part, we will click on create, and then you will select the circuits part. So it's the middle one, circuit. Awesome. There we go. And you will be seeing kind of like this nice blank screen, and you will have like all of the components over here that you can select from. Well, we learn we learn something new every day. Yes, that's so true. I mean, I learn a lot from my streams, because then like hackers come in with different ideas and different softwares that they use. I have to admit, I can learn a lot from you all. So if you always have something new to share or something that you would like to see on the stream, you can always let me know. I mean, I'm pretty open to pretty much everything. Honestly. Great. So to get started, we're just going to see like kind of like the basic things, which are just like Arduino 101. So as I mentioned before, Arduino, it's a microcontroller. So microcontroller is kind of like the brain that controls everything that you will be building on your project. It can be a smart house, it can be a smart vehicle, it can be, I don't know, a smart TV. All of those devices, they have microcontrollers, which are basically just embedded circuits, I'm sorry, that you can use to connect pretty much all of the components that you will see today. So over here, you will be able to see, if you scroll down or you click on the search bar and search, we can search for the Arduino. And if you click on Arduino, you can see like the different examples, and I will make my screen bigger. I cannot make it bigger. That's sad. Yeah, but we have different Arduinos over here. I mean, we have some already built-in examples over here. We're not going to click on those yet, because we want to learn the basics first before actually going into more complex topics. So first thing that you have to do is select Arduino R3, which I think it's the only one that they have on the simulator, and you're going to drag and drop it on your working area. Oh my god, that was too big. Great. Okay, I think that's big enough for all of you to see the board. Yeah, you just have to drag and drop it, and it should pop on. Basic things to know about this, and now that you can actually see a nice image for yourselves. Honestly, this is how it looks in real life. I'm angry with myself that I didn't brought like all of my hardware pieces, because today I was like as today is Women's Day, I was in a celebration, in an event, and I didn't got to bring like my backpack with me. And as a robotics student, I always carry like a lot of hardware stuff in my backpack. I have like different Arduinos, I have Raspberry Pis, I have cameras, I have cables. I have a lot of things in my backpack, and I'm just very sad that I didn't brought it for the stream. But I promise you, I will show you some real life hardware tomorrow. Yes, because I just brought my purse today, so I don't have my robotics kit. Great, but this should work. I mean, you will get to know it eventually. Awesome. Yes. This is the Arduino Uno. Yeah, great. So, basic things to know about this. Over here, we have the power cable. So this is the cable that you basically use to plug in the Arduino with your computer. So this cable, if you were to see it like on real life, it will be kind of like a USB cable. So the USB cable, you basically plug it in into your computer, and then you connect it into the Arduino, and you upload the code through the software of Arduino. For now, as we will be doing a simulation, we will be doing it over here. But perhaps tomorrow we have some free time, I can run it on my computer, and you can see like how it works if it's physical. But it is basically the same, just like in the simulator. I used Arduino to make a sonar scanner for my college science project. Oh, that's very nice. That's a cool project. I will definitely love to learn more. That sounds very very cool. Great. So after adding the Arduino, we're going to add the second component, which will be called a breadboard. Oh, no, I don't want this. Oh my God, no. Don't mind me. In the search bar, you're going to search for bread. Why is it not typing? There it is, breadboard. You can select the small breadboard. It doesn't matter which one you select. And I will tell you why we use this in electronics. Let me just make this a little bit smaller. No, I don't want to do cables right now. There we go. I'm going to place it right next to it. It doesn't matter where you place it. It's just another different component. And I'm going to zoom in a little bit so you can see what I'm talking about. Great. So we're going to learn the basic parts on how to making your Arduino be connected with different components. So let's imagine that you have to connect like a lot of things into your Arduino. So you want to have like your camera, you want to have like 4 motors, you need to have like temperature sensor, a buzzer, some LEDs, some display lights. So you want to have like a lot of components, and over here there are not enough pins to connect like all of the components that you want. So to do that, instead of having like the components plugged in directly into your Arduino, you're going to pass that on into your breadboard. So the breadboard is just basically kind of like a space where you can connect your components. I mean, it doesn't have any another functionality. It's just a space to connect components. It's not a microcontroller. It's not a sensor. It's just to plug in cables. In short terms. So we're going to plug in our first cables and we're going to learn about them. So over here in the Arduino, if you're seeing, there's a thing called power. So power is everything related into giving, power or energy to your components. So we have different pins over here. We have G and D. So G and D is basically ground. And then we have 5V and 3.3V, which is 5 volts and 3.3 volts. So, and over here in our breadboard, we have the minus sign and we have the plus sign. So now question to the chat, which one goes with which for the people who are already a little bit familiar with some hardware or some circuits part? So if I were to connect this over here, for example, the G and D, where will I have to connect it? Into the minus sign or into the plus sign? And I will leave the chat open for people to tell me or perhaps research super fast if they can answer this question. Let's see. Great. So yes, so both will be to the positive and G and D will be to the negative. And if you forget this, just remember, if you are talking about ground, the ground and it's kind of like dirt, it's kind of like the soil, so it's black. So you can remember in that way if you don't want to get into the technical terms about it. So yes, we're going to connect the ground, the G and D, into the minus sign over here. So just plug it in. And then the 5B, we're going to connect it over here on the plus sign. Great. So it doesn't matter. It doesn't matter where you connect it. Because by connecting it over here, it gives power to all of these lines. So everything that you connect over here will have power because you already connected this cable over here. And let me actually see if I can change the color of this. You don't have to change it. I'm just making it because I'm very kind of like want to use like the correct color cables. And this one will be red. There we go. Great. So now all of this line will have power, and now we can actually connect our components in here, and we can just, connect it, and it will have power. Great. So now that we connected our breadboard and given it power, now we're going to connect our first component. So our first component, it's the LED, and it's just a LED light, nothing more. So this component, our little flashing light, will be a LED, LED. I think that's the correct pronunciation. And you can drop it in whatever you want. It doesn't matter. It can be literally anywhere. There's no preference. Just place it there. And you can also change the color. This one's red, but you can also make it orange, or you can make it yellow. Oh, I'm going to make it orange. I didn't know there were orange LEDs. So I'm going to make it orange. You can choose any color that you want, honestly. Great. So now, after placing our LED light and before connecting into power, we need to learn another important thing before doing this. So for this, we're going to search for, I don't know what's the name in English. I actually forgot it in Spanish. Oh, there it is, resistor. It's called resistor. So if I were to connect this LED light into my power, it will burn. Why? Because the LED doesn't support like this voltage amount, so it will probably burn eventually. I mean, it will turn on, but it will burn eventually because it's too much power for the little guy. So instead of doing that, we need to add something to kind of like retain the voltage that it's being sent into our LED, so it doesn't die and burn and then like ruin your whole circuit. So in order to do that, we need to add a thing called resistor, and the resistor will basically kind of like hold in the voltage. Instead of sending it through the LED, it's just going to retain it over there, and it's very nice. A resistor looks kind of like a peanut, so it's very cute. So you're going to bring in the resistor and you're going to place it. You can place it here, but then you need to connect this. Um, I don't like this. Let me arrange it better. Hmm. I think that will make it. Yes, because it's very big. It's taking like all of the space over here. But there we go. I think it's connected. I think there's no need to do that. Let's just try it like that and see if it works. Great. Oh, very big. Awesome. So by this, and I can show you what happens if I remove this, is that my LED will burn. So let me actually remove this. Let me remove this. And let's connect our LED. So right now I'm going to connect the LED without the resistor so you can see how it burns, and so you can see what you don't have to do. I mean, you can do it just to have some fun, and just don't do it in real life, because then, I mean, nothing bad would happen. It's not like it's going to explode or anything, but it will be really hot and it will look like super bright, and then it will just die. It will like slowly shut down, and then like the little like wires that are inside, they're going to be burned. And I mean, this is just a LED light, but imagine if you were working with a more complex component, like something that is more expensive, then you don't want to burn that because that's expensive, right? So LEDs are just like super cheap, but like if you are using like a more expensive component, then that will be like super bad, because you will basically be wasting like your money. Awesome. So let's connect it. And before that, just so we know, there are two legs for the LED. We have the positive LED and the negative LED. So the positive leg, we're going to connect it into a digital pin. So here's another important concept for our Arduino, is that we have different types of pins. So we have digital pins and we have analog pins. By any chance, anyone knows the difference between a digital pin and an analog pin? I will be very impressed if someone knows that, because that's kind of like an exam question if you're studying like something electronic engineering related. Let's give some minutes. I'm pretty sure there's going to be a hacker that knows. I have faith. I have faith. Um, it's very hot here in Mexico right now. It's like 40 degrees Celsius. That's why I'm drinking like so much water, because I was outside just like a while ago before like arriving into the library where I'm at right now. It was very, very hot. It was very intense. Analog works on continuous supply. Digital works on 0 and 1. Okay, I love that answer. 0 and 1. Yes. Does it have to do something with waves? Honestly, yes. If you see the signal, it's just basically kind of like waves, and we can search that if you want, like digital signal versus analog signal. And I don't want to get like very deeply into these because it's not very beginner friendly, but yes, moses it has to do with waves. So analog, if you can see the signal, it's kind of like a nice curved wave that has different values. And digital signal, as another hacker mentioned, is basically like 0 and 1. So you only have like these two options, like 0 or 1. And analog, you have different variety of options. Great. So, follow-up question now. Why would you think, which signal do you think an LED is? Digital or analog? If I mention digital signal can only have two values, like 0 and 1, and analog can have like, I don't know, like 54 or like minus 53. Yes, digital. So LED is basically digital. Why? Because you can only turn it on and turn it off. Yes, that's correct. Very glad to see a lot of participation over there. So now you know something more, more specific about how the LED works, which is just basically, having two states. So you can either turn the LED on or you can turn the LED off. And so now when connecting this, we're going to connect it to a digital pin. So the digital pins are the ones that don't have like this weird bar over here. So 8, 12, 13, 7, 4, 2. I mean, you can still connect it like in any pin that you want, but I would rather recommend you to connect it in the pins that don't have like the analog signal sign. Great. So for the digitals, you can actually connect it anywhere, but like for the analogs, you actually have to specifically connect them into the weird sign thing bar that's like before the number. Great. So it moved. Great. So let's connect the first one. So this will go to, I will place it on the two. Sorry. And then give me a moment. There we go. Great. So the first one, you're going to connect it to the two, and then the other one, you're just going to connect it into the minus one over here. Because I mean, I can directly connect this one into the negative over here, but as I'm trying to keep things a little bit more titty, you can do this because if you know and if you remember, this line has power, so it will be connected. Great. So let me change this into, I want to change this into black. And this one, let's change it, I don't know, to orange because it's an LED one. Great. So right now we don't have any resistor in here. So when I turn it on, it will very probably burn. So now that we have our circuit connected, we can move on into the software part. So for the software part, you're going to click on this little button over here that says code. So let's click on that. And over here, you have different options. So we can either go with the blocks part or we can go into the text part. Currently will be lost. And yeah, continue. We can figure it out later. Or you can also go with the text part, which is basically the code that it's not like it's not very beginner friendly, but this is actually how it looks like. So this is how it looks like in real life, in your Arduino IDE if you were to use that. Honestly, over here, I'm going to ask the chat what you prefer, if we use the C++ code or if we start with the blocks over here. How are you feeling, chat? What would you prefer, either blocks or text? Well, C++. Okay, so we have one C++. Code, please. Okay, we're going to go with the coding part. C++. Awesome. So let's go. Let's change it into the text bar. And I think this has a kind of like this is basically kind of like the very simplest example. Because this code, what it's basically doing, and firstly, I want to make an introduction about how Arduino code looks like. I mean, it's still C++, but it's kind of like a little bit different. So it has like a different structure. So we have two main loops. We have the void setup, and then we have the void loop. So the void setup is basically to declare all of the things that you want to use in your circuit. So in this case, will be the LED. And then on the loop, you place all of the functionalities that you want your component to do, which will be, in this case, turn on the light. So for this example of C++ code, and we can actually run this, let's click on Start Simulation. What this will do, it will just basically turn on the light that it's on our built-in Arduino. So if you're seeing it turn on over here, the light is blinking. And if I stop it, then it's not blinking anymore. Oh, let me make it bigger. There it is. Let me run it again. And now it's blinking again. That's the simplest example that it's already coded into our code over here. And to explain it a little bit more, here is the pin mode, because you have to select the type of pin that you are going to use. In this case, we are using the LED built-in, which is this one. This is the name of the variable. And then we are declaring our port as output. Why? Because we are outputting a signal. We are not receiving anything in. We are just outputting something. And then over here on the loop is what will be basically running for as long as the code is connected. So over here we have our digital right. As we mentioned earlier, our LED is a digital signal. So it's either 0 and 1. So 1 will be high and 0 will be low. So over here, again, you place the name of the component that you want to use, and then you place the signal that you want to send. And the signal in this case is high. Why? Because we want to turn it on. So it is high is basically 1. And then we add a delay, which is basically just to wait for 1,000 milliseconds and then turn it off again. And then again, the delay, and this will basically make it blink. So that's why when I run it, it's our LED is blinking for 1,000 milliseconds. Great. So I have some comments over here that says, what about blobs plus text? I haven't tried that. Let's see how it looks like. Oh, nice. So it has both options. Okay, I will do both then. I think we can do that. Yes, we can make that work. Let me just make the Arduino thing smaller so we can see. Let's see if we can make this. I cannot make this smaller. Perhaps the code. Oh well, if not, I will just close the window and open it again. Scratch. It's kind of similar. I mean, it's still block programming, so you need to drag and drop different blocks in order to make it work. But it's not a Scratch directly. It looks a lot like it, though it's not. Yeah, that's a good idea. The code plus the blocks. Awesome. So this is just basically the same. It has a loop, which is the forever loop. And then set built-in LED to high, which is basically turning it on. And then set the built-in LED to low, which is basically turning it off. And then if we run it again, it will just turn it on and off. There it is. Great. So now instead of making this LED turn on, we want this one to turn on over here. So to do that, first, let's try it on the simulator with the blocks. So let's actually delete this one. I think you can delete it. Yeah, just dragging it up there. So we will keep the forever loop, and instead of doing that, I'm actually figuring this out right now. Like I don't know how to use this. I'm just learning this as well. I think it's a set pin 0 which in this case it's not 0, it's pin 2. Why? Because I selected pin 2. But in case that you selected like a different pin over here, change it into the one that you selected. So set pin 2 high, and then let's see, wait for 1 second, and then set pin too low, and then again wait 1 second. Okay, I mean, this looks nice. Oh, and that's nice because now it changed my code, if you can see. I mean, I'm very familiar with writing this, but I've never used like the blocks part. I mean, I know the blocks part should be like easier, but I think it's being more challenging to me now instead of just like writing the Arduino code. Oh, but this is nice because when I was changing this, it's starting to change the code. That's very cool. That's very cool. Especially for people that are learning, this is super helpful. I will have loved to know that before, earlier in my career as well. Great. So let's try to turn it on and see what happens. There it is. And if you can see, it's burning. Like it has like the warning sign over there saying that it's like, oh no, like it's burning. Our LEDs died. And I think eventually, if you keep it running, it will explode like in the simulation. It's very funny. I don't know if it was like this software or another one, that it just like explodes and there's like a little fire in your circuit. It's very nice. Great. So let's stop this, and now let's make our LED not burn. So to do that, let's just add our resistor over here. Let's just drag and drop it. Oh, there it is. So let's just drag and drop it over here. And let's move this cable on the end over here. There we go. And let's click on code and start simulation. Oh, it's still burning. Why? What does it say? I want to see the warning message. Because also another thing that you need to know is that the resistors have like different how do I call it, different like values that they can take in, and those values that they can take in are denoted by the different lines that are on the resistor, which are basically these lines. So depending on the lines that you have, it's the value that it's going to have. And these things are like super little. They're just like tiny little things. Oh, I think my screen froze a little bit. But yes, I was mentioning that these things, like in real life, they're like super small. They're like just like this big. They're like little peanuts. They're very cute. I like them. Oh, do you see that? It's kind of like saying like, oh, like it's burning, like it's exploding. But now I don't know why it's not taking the resistors. It's not connected correctly. Let me check. Let me stop this. And let's move this thing over here. Oh, it's not letting me. Oh, I think it was not connected. Let's see if we leave it here and then connect this one. Oh, it has like another cable that is there. Let's delete this cable. I mean, it should work for other people, but there it is. Now I deleted the cable that was wrong, and now I can connect this one over here. I want mine to explode. It's not showing a warning or anything. Yeah, the thing is that I had like a hidden cable that went like from one point of the resistor to another one. So perhaps that's why my resistor was not working. I think it should be working now, though. Uh, my screen is like super zoomed in right now because I wanted for you to see it like on the screen. Oh, it's it. Oh, now I. Oh my god. Yes, I could. Yes, that's so true. I connected the wrong LED terminal. Me too. Okay, so then we have like two hackers that actually managed to connect the resistor correctly. Yes, it's not on this one. Let's change it over. There we go. We connect this over here. This one, let's move it. There we go. Oh, there it is. Great. Now it's just dead because I changed it. Wait, give me a moment. This one's over here. Um, oh no. Now it's going to be like all orange. I don't like that. Let's delete this. Let's just start clean. This one over here. This one over here. And then this one. Oh, wait. Let me make it smaller. Oh, this one will go to the number 2 over here. There it is. I mean, it doesn't look very good. But well, what? Why is it still? Why? Oh, it showed the warning. Oh, it is actually showing me like the current. It would be very nice to show that. Because for people who are learning about electronics, they might know that there are like different values that go on over there, and I want to see the warning because it's actually telling me like how much current and how much energy is going through my LED that's making it work. This is my first time playing with hardware. It feels so much more different than software because it obeys the laws of the real world physics. Yes, I mean, sometimes I have to tell you that sometimes, because then there are sometimes that your hardware just like unexpectedly decides like not to work, and then that's super stressing, and then it's just like you forgot something or like you are not doing something correctly. I mean, I like it because you get to interact with like physical things and you get to see like the results like face to face as well. Great. Are we giving it too much voltage or is 5B fine? Honestly, you can change it to 3B and wait, I'm realizing yes, I'm seeing a mistake over here. Um is it connected? No, it's in the 5D. You can change it to 3.3. I mean 5 should be fine with the resistor. Something important to know as well is that the Arduinos, they're set to manage like power sources that are like 12 volts. So if you are using like if you're controlling like I don't know like some motors or like some more complex things, then you might need like more voltage, and you can connect like an external computer, an external battery that's like 12 volts, which will make it work. Just that when you are dealing with more voltage, then you have to be careful because I mean, it might not only burn your circuit, but it might also like harm you as well if you don't manage it properly. This is IoT, so I have to say there, yes and no, because right now we are basically building the hardware that we need, and then tomorrow we will be connecting this to the cloud. So I mean, it's IoT because for IoT, you need to build like the hardware components and then the information that you are sending in over here, instead of like doing it with the code over here, you are basically going to be sending like the signal over the internet to control like your LED light. So instead of having it like in your how do I say, like on your local computer, you are going to have it like in a server or something like um, going on in there. Uh, Longer lead in LED is positive. Oh yes, that there's a difference between the long and the short one. I mean, honestly, like I always confuse when people tell me like the anode and cathode. Like I always mess them up. I think that's what happened today. Yes, but there's a difference. Yes, one is positive and one is negative. I mean, formerly they are named like cathode and anode, but as this hacker is saying, yes, longer leading LED is positive. So when you have your LED, you will see that one leg is like it's longer than the other one, and that one should be the positive one. So this is just a T, no I yet. Yes, basically yes. So you have like the tech part, you have like the hardware part, but then you will have to connect it to the internet as well. So before we move on to our last example that I want to show you, I want to show you an actual project that I did on IoT, but I just don't remember if I had pictures. Let me try to see if on the GitHub I placed like some pictures of it. Because for a class, I had to build like a smart house, and the smart house had like different components, and it had like camera, it had like LEDs, it had like some infrared sensors, it had like ultrasonic sensors. And it was like a very nice kind of like doll house, and you could actually like control that. So let me try to find the repository. I think it was called like IoT something. Oh, there it is, dashboard IoT. Oh, I think I didn't place a video over here. That I mean, there's a Streamlit app. I think I can share this with you in case you want to see like an IoT applied project. Because in university, I actually had a course that was about Internet of Things, and we basically saw like databases management in SQL, and then we saw like the Arduino part, which was like super easy. And then we had to connect it. We had to connect like our SQL database with our sensors through like an internet API to send in information. And let's see if this the app is still running. If not, I can bring it back up. There it is. I think it will start loading in a while. Which tool did you use to create your GitHub profile page? It's awesome. Oh yes, I can share with you. I think I actually made a stream about building a README profile. I think it's we can just search like README template generator. Let me see if I can find the exact one that I use. Perhaps this one. Oh, yep, this one. There it is. Let me share it on the chat as well. Why is this like super there it is. I share with you the template. I think this one's one, but I think there's another one that's also cool. Is it this one? Oh yes, this one's the good one. This one's the good one. Don't mind the first one. This one's the cool one because you can just like drag in like the different things, and you can see like different templates in here. Oh, this one's nice. Yeah, that's a little bit extra, but yes. Oh, I think it's living. Perhaps it will show errors with the data because the sensors are not connected. But yes, it was basically like a dashboard that was like a smart house, and the smart house was basically focused like on security. So it was like like a large security system. Let's see. It's not. I think that our free database access is dead. But yes, it basically showed like the different how do you call it, like the different connections that our sensors had like with the dashboard and stuff. So sad that I can find the video. I mean, I have no idea why I didn't place it like on the readme. I always put like so much effort on my readme sections. Why didn't I place my YouTube video here? But yes, if I find the YouTube video, I will let you know afterwards. Great. So yes, that was just an example. Perhaps I can find it by tomorrow and show you like the video so you can see how it works. But let's see. Great. So as a final example, let me make this smaller and close the code part. I will look for a nice example that we can use, like from the circuit. So let's try to think of something simple. Why is this super big? Oh, there it is. Great. So let's search Arduino and let's try to find a simple example. Breadboard, blink, fade, analog read serial, tone pitch follower. I mean, there's a lot of examples over here. You can feel free and play with them. All you have to do is honestly like just like click on them, and then it should work. For example, this one's called NeoPixel. I don't even know. I have never seen that one. Oh, mm, there it is. It's kind of like a long LED strip, but I want to move it. Let me delete. You're about to delete one or more program. Yeah, doesn't matter. Just want to clean my workspace area. Let's see how the code looks. This one's actually more complex. Let's try to figure it out by ourselves and me as well. So in this case, we are using LED strip, which is probably kind of like what gaming people use, like the LED strips that are kind of like in the top of the floor of the ceiling. I'm sorry, and it's very. This looks simple. It's just like a digital signal, and then we have like the 5 volts, and then the ground part, and yep. Yep. So for the code, let's see. So we have the library. This is just a library, as if you were working with Python. You need to import some of the methods that you need to use in order to use this component, because some components are more complex than others, and some components actually need you to have like different libraries. And then in this case, we are just declaring the object from Adafruit NeoPixel, which is called pixels, and then we just tell it like the number of pins that it's going to have and some like extra configurations about the rate that it will be running from. Then over here we have different variables. We have red color, green color, blue color, because I'm assuming this LED strip will basically connect to the strip, and if you add like different combinations of these colors, then it will display like the color that you want. Then on the void setup, we just have the object initialization, which is just pixels.begin. And then on our forever loop, we have kind of like a bit more complex loop. So we have a for loop that iterates on the different number of pixels. So the number of pixels is just basically number of neopixels in the strip. So the different kind of like LEDs that we have. So it's a different number of non-pixels. Can you show how you got that set up again, please? Yes. So you're going to go into the components over here, and you're going to search like for Arduino. And then in here, if you scroll down, you will see eventually the NeoPixel thing over here. I hope that works. Great. So awesome. Great. So in here, we're just iterating over each different LED strip, which is just like a non-pixel. And then in here we have a comment that says pixels.color takes RGB values from 000 up to 255 and so on. So we can make our own combinations to display different colors, which in this case, they're just basically picking like random colors for red, green, and blue, which is just what they are doing. And then they use this method, pixels.show, which is a specific method of this library to show the color of the hardware. And then finally, they add a delay. And yes, the set color, they're just placing like random colors to place like on the LED strips. Great. So I mean, I think if we run this, it will work. So let's try to run it and see how it works. Oh, it's very pretty. Now it's displaying like different colors from different for the random. I mean, it's just like random combinations of colors. And if you were like to show like a specific color, then you will just have to change this method to place, instead of random, be like a very specific color. Awesome. So, oh, my battery. Honestly, so this is very cool. I think we learned a lot on the course of this stream. I'm going to stop this. So for tomorrow, we're going to see now how we can actually connect this with the cloud. And I promise you, I will bring you the hardware pieces that I mentioned throughout the stream, so you can actually see like how it works. And and then after that, we're going to use another software to connect our code with the cloud, so we can actually send information through the internet. Is there any reason why they use define for pin and num pixels? Let's see again. Define pin, input pin, neoc pixel it's attached to, and then in num pixels. Oh yes, so num pixels is like the numbers of like tiny white things that you have on your LED strip, and then pin is just like the general thing that the whole strip is like connected into. I think that that should solve your question in there. Great. So awesome. Great. So for tomorrow, it's yes, as I think someone mentioned on the stream. So in here, we're just basically seeing kind of like the technology part, but tomorrow we're going to see like the internet part. So to do that, I will try to do like a nice presentation to explain how the API works with the components, in case people are not familiar with APIs. And then we will hopefully be able to publish like some information. I mean, it might be something very similar. It's very simple, like just like turning on a LED like on and off. Still, it's a very complex process, and if we manage to do it, then we should be like super good to go, and you are doing like a super awesome job. Great. So I will see you all tomorrow, which will be Sunday. I think it's on the morning. Still, I will remind you on Discord as well when you are able to see there. Thank you very much, and I have a really nice time. I hope you as well, and you learn about some hardware stuff. Great. So until tomorrow, this is everything for me, and have a nice evening or morning or perhaps afternoon, whatever you are located. Great. Bye.